Question number 46. It says find the Laplace transform for this particular integral expression. So how can we find that? This is basically obtained by using the concept of convolution. So based on the output, you are also asked to evaluate this improper integral. So the solution goes like this. The Laplace of the integral expression is basically the same as the Laplace of the convolution of these two functions, t squared and t is a power of t. The reason is because the convolution of two functions can be defined as, you see, the convolution of f and g can be defined as the integral from 0 to t of f of t times g of t minus tau. And if you observe the convolution of these two, you will come across with these integral expressions. Okay, just go back and read about convolution of two functions. Okay, so we can obtain that the Laplace of the integral is the same as the Laplace of the convolution of these two. But as we derived in the classroom, the Laplace of the convolution of two different functions is the same as the Laplace of the function times the first function times the Laplace of the second function. So this will be the Laplace of t squared times the Laplace of t e is a power of t. And we know that the Laplace of t squared is 2 factorial over s the power of 2 plus 1, which actually is 2 factorial 2 over s cubed. As you see, it is 2 factorial over s to the power of 3. But here we need to, what, students? It derivates the Laplace of e to the power of t. We know that the Laplace of e to the power of t is 1 over s minus 1. So as you know, the exponent here is 1, so we need to derivate 1 over s minus 1 once. The number of order of this derivative is, you see, mattered by the exponent here. Since we are having 1 here as exponent for t, we need to carry out first derivative. Not only this, the other thing that you need to get into account is whenever you look for the Laplace of t to the power of n times a certain function, you must have a sign indicator minus 1 to the power of n. Here the exponent for t is 1, so minus 1 to the power of 1 will be negative 1. So this negative is written in front because of this reason. So now we need to undergo the first derivative of this one. So the first derivative of this can easily be obtained using quotient rule. As you know, this will be 0 and minus 1 over s minus 1 the whole squared. And the minus sign cancels the minus sign, and then finally 2 in 2 over s cubed s minus 1 the whole squared can come. So dear students, the Laplace of this expression now is obtained to be 2 over s cubed into s minus 1 the whole squared. Once you determine this, you are also asked to determine the improper integral here, this double integral. So in order to obtain this one, you just need to apply the definition. The Laplace of this integral expression by definition is the integral from 0 to infinity of e to the power of minus st times the function given. The function given here is, you see, this expression, so you would just simply copy and paste here. So look, student, now e to the power of minus st for this particular integral is nothing because the integration is done with respect to tau, so we can put this one inside here and then we can have this expression as you see, no problem. But now compare the one we are having here with the one written here. What difference can you observe? Everything is the same except the fact that here in s we are having 3 there. So if s is taken to be 3, these two are going to be identical. Thus, you see, we knew that this has been already obtained as 2 over s cubed into s minus 1 the whole squared, as you see here. So directly when you come to this, or when you just use s to be 3, this expression can be obtained. You see, the question we were having at the beginning, this one can come when s is 3. So put 3 here, so you will get this to be, as can be shown this expression, the question we are having. So as you are putting 3 in s, you do the same for the right expression too. You must put 3 again here, okay, to keep equivalence between the two. So this will be 2 over 3 cubed into 3 minus 1 the whole squared. So after simplifying this, one can get the answer to be 1 over 54. So although this equation express this sort of, you see, double integral looks as if it's difficult to find its integral. Thanks to the concept of this Laplace transform, we can obtain that to be 1 over 54, just using the definition alone. Next from this, we have another question, and that is question number 47. It says, find the Laplace transform of the function f of t, which is given by e to the power of minus 4t into the integral 0 to t of t squared e to the power of 2t dt. So for this again, we just need to apply the property, one of the properties we saw in the Laplace transformation. The Laplace of t to the power of n times f of t is nothing but it's equivalent to minus 1 the power of n of the nth derivative of the Laplace of f of t, which actually is f of s. So you have to recall this one, okay? So when you come to e to the power of 2t, we first, you see, need to determine the Laplace of e to the power of 2t, and then we will try to apply second derivative of that, as can be shown. If you consider n to be 2 and f of t to be e to the power of 2t, you can have here t squared e to the power of 2t. So you are expected to carry out this minus 1 the power of 2 of the second derivative of the Laplace of e to the power of 2t, which actually is 1 over s minus 2. So clearly, as I said, Laplace of t squared e to the power of 2t is minus 1 squared d squared ds squared 1 over s minus 2. This is basically used because here as exponent for t we are having a 2, so minus 1 to the power of 2, and the second derivative of the Laplace of this is a power of 2t, which actually was f of t, which was f of s 1 over s minus 2 for the time being is used. Now look students, we need to carry out the second derivative of this one. Basically negative 1 square is 1, so no need of worrying about the sign here. So the second derivative of 1 over s minus 2 is going to come. In order to carry out second derivative of this, you need to recall quotient rule. So using quotient rule, one can obtain simply the second derivative of this expression. So clearly the second derivative of 1 over s minus 2 is going to be 2 over s minus 2 cubed. Okay, 2 over s minus 2 cubed is the second derivative of what, students? This expression 1 over s minus 2, which actually is also the Laplace for t squared is a power of 2t. So now consider this as your f of s. Look now, student, here. We are again expected to carry out the integral from 0 to t of what, students? This t squared is a power of 2t dt. So from this, what follows is the Laplace of the integral from 0 to t of f of tau d tau is f of s over s. This is from what we studied before, from what we stated under the properties of, you see, the Laplace transform. So what has been obtained now here is what? The Laplace of the integrand expression, like t squared is a power of 2t. So we consider this one as f of s. So now the Laplace of the integral expression alone is going to be what? This expression f of s divided by s. So you simply put s here, and then you will have 2 over s into s minus 2 cubed. So look, the Laplace of the integrals from 0 to t of tau squared is a power of 2 tau d tau is going to be 2 over s minus 2 cubed over s, because your f of s is taken to be this one, and that has to be divided by s. So this makes finally 2 over s into s minus 2 cubed. But my new students, we didn't finish yet, because once you obtain this Laplace transform, you see, now you need to find the Laplace transform of e to the power of minus 40 times this expression. And remember, students, we said that if you are able to determine the Laplace transform of this one as f of s, then the Laplace transform of, you see, this one together with this makes matter of putting s minus s plus 4 in s of the Laplace transform of this expression, okay? Once you finish finding the Laplace transform of, you see, the integral expression, in s of this obtained, okay, this obtained Laplace transform of this function, you simply put s plus 4, because we are multiplying by this minus is a power of minus 40. So in s of this expression, we are going to put s plus 4, right? Therefore, What comes next is this one. The Laplace of e to the power of minus 40 is going to be, times this expression is going to be 2 over. Now look, what have I done here is I simply substituted s plus 4 in s expression throughout. Look, s plus 4 is used, s plus 4 is used. Then minus 2, the power of 3 can come. Now we can simplify this because 4 minus 2 makes 2, so s plus 2 cubed can come. So finally, you will obtain this to be 2 over s plus 4 into s plus 2 cube. So the Laplace transform of the given function comes as it is. So students, in order to answer such kind of, you see, Laplace transform question, what you need to recall is you have to know basic Laplace transform of certain functions. Second, you need to remember those important properties we stated before. I hope everything is simple.